Hello students, Professor Dr. Mink, and welcome to another incredibly interesting, riveting lecture for CompSci 2. Um, the topic at hand is iterators, and I'm a little conflicted about the sequence the author of our textbook chose to present iterators, which is after lists. And iterators were touched upon and used in lists, but life's not perfect, I guess. So let's get started and drill down on this topic. Iterators are a luxury. We could, given various methods in classes that represent collections, lists, stacks, queues, etc., we could write our own code to access the elements in a collection, and it might be different for a queue or a stack or a list. But the iterator takes care of that for us. So we're going to cover the purpose of an iterator, which I've already, excuse me, I've already touched on. The iterator and iterable interfaces, the concept of a fail-fast collection, how we use iterators to solve problems, and how we implement iterators. An iterator is an object that provides a set of tools for acquiring and using elements in a collection. It works with a collection, but it is a separate object. And so it replaces the need for us to write methods with code that is specifically focused on processing a collection, a list, a queue, a stack of objects, elements. So it simplifies that step of walking through inspecting, modifying, adding, removing, processing elements in a collection. In the Java API, we're provided with two interfaces related to iterators. And the first is the iterator interface, which is necessary to define an iterator. The iterable interface is used to define a collection that provides an iterator. It is said that a collection is iterable when it provides an iterator as requested. I know that sounds confusing, but we are going to drill down on this and simplify that so that it is much easier to understand. Okay, you'll never know this, but this is the fourth time I'm recording this slide because I got tongue-tied switching between iterator and iterable and interface. Sorry, thought you might laugh at that one. So this slide depicts the methods in the iterator interface and the iterable interface. The methods has next, which returns a Boolean, very useful in stepping through until we have run out of elements, objects. So it returns true if it has a next element to process. And then we've got the method next, which returns the next element in the iteration. And we have remove. And we also have in the iterable interface a constructor that returns an iterator over a set of elements of type E. Getting clear, I hope. So here's how we use the two. Let's assume we have my list which is an array list of book objects. So the first line we have obtains the iterator. Then the loop uses has next and next to access and print each book object in the iterator. So if my list is iterable, a for each loop can be used in the same way as the while loop. And here is the statements. The for each loop uses an iterator behind the scenes, and it can be used on any object that is iterable. And in this case, my list, which is a list of books, is iterable. In the case we just reviewed, the for each loop doesn't give direct access to the iterator. So you can't call removed if you're searching for a specific element. So you would use an iterator explicitly if you're not going to process all elements in the collection. So for example, if you're searching for a particular element, or if you obviously, as previously stated, if you want to remove an element from the collection, from the list. The iterator does not dictate the order of the elements. And you can't assume that an iterator is going to process those elements in any particular order. It's just simply accessing the elements stored in the collection, and the structure of the underlying collection, linked list, array, etc. Cannot be changed while an iterator is being used. And I thought it was all iterators in the API were fail fast, but I'll assume the author of the textbook might know a little more than me. He claims that most iterators in the Java API are fail fast, which means they'll throw an exception if the collection is modified while the iterator is active. Earlier in this module, I mentioned that I was conflicted regarding the sequence in which lists and iterable and iterator interfaces are presented. And here's a classic example of why. Because program of study was a class that we used to build a kind of a transcript, if you will, in the last module. And here it is introduced or reintroduced or referenced as we're studying iterable. So program of study implements the iterable interface, and the iterable method returns the iterator provided by the list. The POS grades class uses a for each loop to print courses with a grade of A or A minus. And obviously, we're going to take another look at that momentarily. So here we are back at the program of study class. Remember, the program of study creates a list of courses. And please notice the program of study class implements the iterable interface with regard to courses. So, and here it is. We have public iterator, course, iterator. And we return a list.iterator. So this allows us to do things like this. Let's go to this POS grades program. we load the serialized program of study that we saved to a file called program of study with it's a chapter 15 POS program. Yes, couldn't remember the name of the program, but I actually have it sitting up here. So we create a new program of study called POS, and we load it from the serialized output file that we created when we saved POS. And then we just simply print out the entire list. Then we're going to print a header, classes with grades A or A minus. And the iterable interface allows us to do this. For each course in POS, if course.getGrade equals A or course.getGrade equals A minus, let's print out the course. And this for loop will iterate through all of the objects in POS, all of the course objects in POS. So if you want to see this run, well, I already did the run, but I'll run it again just for the sake of posterity. If you recall, the file we created, program study, and we saved it as a serialized object file, had CSC 111, Introduction to Programming A minus, etc. So all of these courses, except for computer organization, which I added and did not add a grade, I didn't initialize that variable. All of them have grades. So then we step through, where is it? Each course in POS, because POS is a program of study and that class implements iterable, we will step through each object and we can inspect the grades and only print out the ones that match A or A minus. I will do another one coming up where we will clear any courses in a program of study that, I'm trying to remember the criteria. I think we clear any course that doesn't have a grade assigned to it, which in this case would be computer organization, but I'm not sure if we generate a new program of study before we do that. So stay tuned, we'll get to it, and obviously I'll give you all the details you need. Next, we'll use the same program of study to remove, and we'll use the iterator in the program of study to remove any course that doesn't already have a grade. And if you recall, computer organization was the only course in the program of study that we built that didn't have a grade. We can't use a for each loop because we're going to use the iterator's remove method. So we'll use a while loop. So let's take a closer look. I probably forgot this disclaimer when we reviewed the POS grades example, but I'm giving you these files in the timeline of Canvas, and needless to say, you have to download these and you have to experiment with them. You're not going to understand how the iterable and iterator work unless you're actually watching this video and downloading the files, playing around with them. And I'll be assigning, I haven't figured out which problem I'm going to assign, but I will assign a problem for a programming problem for this chapter. So anyway, here we have the POS clear program, very similar. New program of study, POS, and we use the load method to load that file, that serialized file that was created with save. Then we print the whole thing. Then we print a header removing courses with no grades. We use iterator, course ITR. So we're declaring an iterator object, and it's pos.iterator. So this will give us access to the hasNext and next methods of the iterator class. So while iterator.hasNext, this will continue to parse each object in the list. So course equals iterator.next if course taken. So let's take a look at course taken. Okay, course taken simply returns a Boolean. If the grade equals null, right, this would return true. So then we flip it with a not. So it's going to return true for all of the courses that are in the list that have a grade. Sorry, got a little tongue-tied for a second there. So if the course is not taken, right, means it doesn't have a grade, we're going to call itr.remove. We're going to remove it from the program of study list. And then we're going to print the program of study list. Now in the file that I'm going to post, you're going to see it saves this at the end as a new program of study. Obviously, I don't want to do this because then I can't demo it more than once. It'll actually delete computer organization from program of study and save it, and then back up here we'd wind up loading it without a course that does not have a grade. So if I run this, oh sorry, I have the output. So here is the original list. We have 1, 2, 3, 4, 5, 6 courses in the program of study. 5 of them have been taken in a grade. Oh boy, this person took computer science 2 and got an F. You know why that happened? I remember that student. That student watched the videos but never downloaded the files and went through them to gain competence. Sorry, couldn't help myself. You know where I'm going here. I did that to put that grade in there deliberately for this reason. So removing courses with no grades, you can see computer organization was removed. Whoops, sorry. Hate when that happens. So if you have any questions, download these files, run them, make sure you get this to work, play around with changing the courses, maybe eliminating a course or adding a course without a grade, and see how this works. Thanks. Have a great day.
When we implemented the ArrayList class, you may or may not have noticed that it contained a private inner class that defines an iterator just for the list. And using an iterator in this way is appropriate because of the intimate relationship the inner class has with the outer class, which is the collection. And it maintains a modification count that is initialized to the current number of elements in the collection. If those counts get out of sync, the iterator throws a current modification exception error. I'm going to show you that inner class in the original ArrayList implementation from the last chapter. Next. Here we're taking a look at the ArrayList iterator inner class which is inside the ArrayList class. And what is important about this is it has this iterator mod count, and before it calls has next, before this calls has next, it checks to see if the iterator mod count is the same as the mod count. And this will return true if the iterator has at least one more element to deliver in the iteration. However, if the collection is changed while the iterator is in use, it throws a modification. I'll leave the entire coded solution in the 3 slides following this so you can review it. But that's basically it. I couldn't fit the entire inner class on one slide, so it's going to span 3 slides, and you can take a look at it over the next 2 slides, but it is what I just showed you. And this is, I believe this is also included in the source code files for this module. And just like the array-based iterators, we can implement link-based iterators. And we're going to show you link-based or linked list iterator class implemented as a private inner class. Here I'm showing you the linked list class from the linked list example we covered in chapter 15. You already have this code, and you could see we've got excuse me, the inner class for the linked list iterator, and it does the same thing. It has this iterator mod count, and if the iterator mod count is different than mod count, in other words, the collection is changed while the iterator is in use, it's going to throw an exception. Yeah, I think that's everything new that I need to cover. This brings us to the end of this lecture. I hope you enjoyed it. I'll leave the code for this inner class in 3 empty slides after this. The video will just go on, and you'll also have this from the chapter 15 source code. And obviously, if you have any questions, don't hesitate to ask me. Thanks for watching. Have a great day.